I study asteroids and comets, and mostly asteroids that could threaten Earth with an impact, but at the same time could also be used for mining, for space mining, because they come really close to the Earth and they have very little gravity. So not only are they a potential threat to Earth, which we are addressing, but they are also a potential resource. Water is the most precious material outside of the Earth's atmosphere once you can extract it from the surfaces of asteroids and then deliver it to the Earth's orbit cheaper than it costs to launch. Then you're going to have a self-sustaining space economy where the water will be produced from the asteroids, broken up into hydrogen and oxygen, used as fuel by all these satellites, and then you would not have to put it into orbit. Putting things into orbit is very expensive. Mining asteroids is very expensive. But once you improve the technology so that the mining is cheaper than putting things into orbit, boy, you're going to open up all kinds of stuff. Right now, there is no asteroid large enough to wipe out civilization that is threatening us. But as a civilization, we must worry about it because large impacts have happened and will happen again unless we avoid them, unless we change the course of the threatening asteroid. But those are also the ones that we have studied in most detail, and those are not threatening us right now. Along those lines, the NASA's DART mission was designed to deflect an asteroid from its course with an impact. And it was an experiment to try to determine if this technique would work. It was a spectacular success. It worked extremely well. The impact of the NASA spacecraft onto this small asteroid that was orbiting a bigger one changed its orbit a lot more than we had anticipated. And so this technique is much more promising than we thought it was, and it is our number one technique to deflect asteroids that would threaten Earth. I became very interested in comets, and maybe because when I was 10 years old, Comet Ikea-Seki came, and it was so spectacular. My father woke my brother and I out, and we went out in this spectacular comet that went from the horizon to the zenith. And so since I was a child, I've been interested in astronomy, specifically in comets. I started studying comets. My PhD thesis was on that. And then there were these strange objects that were kind of like comets, and they had the orbits of comets. And I found asteroids very interesting. So I shifted more into asteroids, although I haven't left comets completely. I am part of a proposal that is being led by Cornell University to build a spacecraft to go to the nucleus of a comet, not an asteroid, and bring back a sample of it. Boy, did it feel good to do my first two hires, which were Dan Britt, Professor Britt, and Professor Fernandez. So we have grown fast. We're very proud of the fact that two of our kind of junior faculty members have gotten the largest NASA grant or NASA contract that UCF has ever gotten for $35 million to build a rover that would study a volcanic area on the moon. It's called Lunar Vice, and that's Professor Donaldson Hanna and Professor Adrian Dove. So I'm just like, wow, I cannot claim any credit for how good these people are, except that I did hire them. So I've been at the right place at the right time, and it's been very rewarding. I'm just really grateful because UCF has been the best decision of my career. Accepting the job at UCF, it kind of looked good at the time, but boy, I had no idea that it was going to be this good. So I am grateful for UCF for giving me a home to develop this group, and that I'm so proud of.